Okay, so I will present my project, which is real-time 3D world generation. And what it basically does, it takes OpenStreetMap data and it converts it into a 3D world at real time, which can be explored in a game engine, and you can move the camera around and view various cities based on real data. So first I want to disclose the AI usage. I did use AI for consulting for new C++ features because I found it really helpful if, for instance, I would have an idea how I would make it, and I was a bit unsure if it was the most elegant or most up-to-date way to do it in C++. For instance, sometimes it's the standard library offers, for instance, something better to measure time than what one is used to, or something else. And I also used it for generating most of the textures for the project, and the 3D trees. The models were also AI generated. But moving forward, my project basically takes the Google Filament engine with CMake, and it basically does the world generation at real time. So it goes through various steps to achieve this, and to allow the world to be loaded, to have an arbitrary size of the world. So for instance, it can't load the entire world at once, so it loads only chunks, and when you move the camera, it loads other chunks and removes the others from the view, similar to some games that use this, like Minecraft or such. And the geometry of the buildings also generated from this data. So it basically extrudes, it takes the outline of the building, and then it generates the triangles and the UV maps and everything it needs to make a 3D model out of it. And it allows basically two ways to do this. One is to just load a pre-downloaded .osm file, which is an OpenStreetMap XML file, or it can also stream this data. So it makes a request at the server from OpenStreetMap, downloads it, and then parses it and generates it. So it's compiled with Clang, because Filament only supports Clang as of now. And my project I've only successfully compiled it on Linux. It uses many packages, and the package management was probably one of the more demanding tasks to do, because on Linux you could have the packages from your package manager, but I thought it would be not so ideal for cross-platform compatibility, so I also integrated CPM, which is CMake project, CMake package manager, which basically downloads the required packages it needs, and it's only worked for 80% or so of the libraries. So for SDL or other libraries, I still had to use the integrated packages. So I will try to prove that. And my project basically has custom structs, which it stores the data in. So it loads from the XML file, it stores it in a struct, which basically represents this OpenStreetMap data. Then this data is converted with various classes, and they basically convert it into a format which basically contains in a struct which basically only contains the data that is relevant for rendering. So for instance, if in the original data there's the outline of the building, if it runs through the converter, it basically maps the coordinates to the in-game coordinates, and it also generates runs through the generator to generate the walls and everything. And yes, there are also lots of textures that are used. They are combined on various layers, and also various materials used. So I implemented classes for these, which basically use a map in the background. So for instance, if I request some texture with the file name, it basically takes that file name as a key for the map, and then it can search if it's already stored in that map, and then it can basically return that reference. Or if it's not found, it will basically load it on demand. And this works pretty well in my testing. And I also have a custom class which basically decides which chunks are loaded next. So it takes a radius around the user and basically computes this has to be loaded, this has to be loaded, and it adds it back to a vector, which includes as the futures of the threads that will generate this data. And yes, each type of object has a separate class, so building and road and terrain and such, they all have a separate class which will contains the code how to generate this, because the data in OpenStreetMap is not as detailed as one would like for 3D rendering. So it basically has to guess some things, or has to basically take some data that's most likely to be reasonable for this kind. So here we have an example how it works. So it would, if this would be the game word, we have various chunks, and if the engine decides, okay, I want to present this chunk, it first computes the coordinates that will be needed for this chunk, and then it starts an SD async. It starts their own thread, which will basically then do all of the processing it needs. So first it starts with a request at the OpenStreetMap API. It downloads that part. Then it has some XML data that it can use. This is then parsed and basically stored in the structs in the various. And these are then passed to the generators and to the converters, and these will return the renderable data, and then this data is added to the main thread, because the engine only supports adding renderable data from one thread, so it has to go back to the main thread, and it will then be added. And this whole process takes a few milliseconds, so it's not that long. So I would like to show the video now, if that's okay. So yes, here you can see how it loads. As the camera is moved, it generates new buildings, and every building has basically a random roof color and a random texture and a random color. So it basically combines some random values to make it increase the variety and to make it visually more appealing. And for the most part, these textures are just random guesses, so they are not really real, but it looks very convincing. But the road data and the outline of the building and how the trees are placed, everything is based on real data. And as you can see, it loads quite fast. And yeah, and it's basically supported for every city in the world, basically. So yes, so these are all the libraries that I used in this project. So it uses SDL for window handling, as already mentioned, Google Filament for the rendering. I made a custom XML parser with a Rapid XML, STB image for texture loading, HTTP lib for loading of the data. And I also included a JSON library because our OpenStreetMap also allows 3D models to be linked to a building. And then it has metadata in JSON format, so I also had to include that. And logging, I have speed log, and for generation of the geometry and for the roof generation, which is a bit more complex, I used the Seagull library, which basically provides all the geometry functions that I need. Yeah, and this brings me to the conclusion. So as of now, a prototype is implemented, and my idea is basically to improve further on this, and it would also be probably used as a good basis for some games. So for instance, this could be used for a racing game where you have real streets, or maybe flight simulators use something similar. And yeah, as of now, this source code is not public, but yeah, okay. And yeah, this concludes my talk for now.
Thank you very much. That actually concludes